Hello and welcome back to the 5th episode in the series of Maths Online tuition videos going through the Edexcel book. We're going to start a new chapter now, chapter 2 from C1, and it's entitled Quadratic Functions. Now in this chapter you're going to go over an old GCSE topic which you'll have come across, quadratic functions, understanding how to solve them using different techniques, and also plotting graphs. So it's a very important chapter, and it's highlighted here. The ability to spot and solve a quadratic function equation is extremely important in A-level mathematics, and I can vouch for that, not just in A-levels but also in university should you go on to study a numerically orientated subject. So let's cover the first part, 2.1. You need to be able to plot graphs of quadratic functions. So you'll have seen this form before in chapter 1. A quadratic. How do we know if an equation is quadratic? Well, it's given away by the highest power being 2. So in this case you can see that ax to the power of 2 plus bx plus c gives us the impression that it's a quadratic. Now if it's got 3 as the highest number, then we'll say it's cubed, okay, and so on and so forth. But just for now I think let's worry about the squared. As we go down we'll see that they've got an example here for us to consider, and this example, okay, is a simple plot and draw graph. So literally all they've done is said draw the graph with the equation y equals x squared minus 3x minus 4 from values of x from minus 10 to minus 2 to plus 5. Now I think everyone knows how to plot a graph, but let's just go over it once more. It's very important with any graph that you know what the axes are. So this is a 2D graph, okay? That should be a horizontal line, sorry about that. And this is the x-axis and this is the y-axis. Now all you need to appreciate is that labeling the axes is very, very important, because from my understanding you can sometimes be deducted marks if you do not correctly label the axes, okay? Now back to the question we have. It says between minus 2 and 5. So they've plot here minus 2 all the way up until 5, and you can see it corresponds to this picture here. They've got minus 2, minus 1, and it goes all the way up to 5 on the x-axis, okay? And all they've simply done now is they've entered the values of x, okay, into this equation to get a y, alright? And that y is going to correspond to the y coordinate here. Very simple, very straightforward, okay? And then it asks you in B, write down the minimum value of y and the value of x for this point. So we can see here that the minimum value is this point, okay? Now in this particular question, the minimum value is well, it's not a whole number, it's a decimal point, okay, which they've given you here. And also the next question is label the line of symmetry. So you can see in the graph what the line of symmetry will be, and again it will be at the minimum, okay? So it says here, this is the line of symmetry. It's always the halfway line between the x-axis crossing points, okay? It has equation x equals 1.5. So again it's where the halfway point is between the x-axis. So let's just move on. You've got some questions here to do. Again, it gives you the values. So all you need to do is just plug the values in as we had done so before, and then we can work out the answers. Okay. There's a hint here. The general shape for question 4 is an upside down shape, i.e. as such. So let me just give you a few terminologies. This is known as the trough, okay, and this is known as the peak. Alright, that's all you need to know in terms of the graph shapes at the moment. Another way to think of it is this is like a U, right, and this is like an N, lowercase n. So moving on to section 2.2, you can solve quadratic equations using factorisation. This is something that we've touched upon beforehand. Let's go through it. So we can see from the example 2, example 2 says, solve the equation. We have x squared equals 9x. Okay, so as I suggested here, they've taken out the common factor, remember that? Okay, taken it out, and then what's secluded within the bracket is what is left. And also it's important for you to realize, a point I should have mentioned is that quadratic equations are always equal to 0 in this particular case. Okay, so that's why we have the 0 on the right hand side. So with this equation here, pretty much all they've said is the following. Let's factorize. So we have x minus 9. Okay, let me do it more clearly. So that's the first step, that's the second step. So they've taken 9x to the other side. So remember, whenever you take one thing from the other side, the sign always changes. Okay, I like to think of it as this going to the other side, but the technical term, or the technical way of understanding it, is that whatever you do on one side, you have to do on the other side. So in this particular case, we've taken away minus 9x. So here we have 9x minus 9x. This cancels out, and this gives us 0, and that is why we're left with this step here. Okay, that's the technically correct way of understanding it. So we have this equal to 0. So this means now that x is equal to 0, okay, or x is equal to plus 9. So the reason for this is, in order for this formula, this equation here to be mathematically correct, x has to be either 0, which we get from this particular x, because if this is 0, then this whole thing will be 0 because it's multiplied, and if this is 9, then inside the brackets we get 0 multiplied by this, it gives 0. Alright? So this is the step that's being conducted here. So we have two solutions, 0 and 9. Okay? Once again, the reason why we have 0 on the right hand side is because when you come to plot a graph, like here, you'll realize that 0 is where the graph crosses the x-axis. Okay, so remember, at this point here, okay, x, y, on this line here, on the y-axis, okay, the y-axis, we have that x is equal to 0. Okay, x, okay, is equal to 0 on y-axis. Okay, and likewise y, okay, is equal to 0 on x-axis. Okay, I can't write axis. Yeah, axis. So this is very important. So when we equate it to 0, that means for our particular case, we'll have here that y, okay, we'll have a point here, and if we imagine that this was 9, we'll have a point here. Okay, so wherever this graph is, okay, it will cross over this point here, right? So going on, moving on, we've got some other examples here. Again, you can do that in your own time. We've got some fractions here, and that's if you get a fraction, okay, don't worry, it doesn't mean you've done something wrong. There are more difficult questions that will have fractions in them. Okay, obviously when you come to plot your graph, okay, you won't be very specific with where you plot it, because essentially this is a decimal point, and unless you've got decimal lines dotted around, dotted on your graph, it's that exact and accurate, which most of the time it won't be. Don't worry about it, you've still got the right answer, hopefully. Again, similar things. You've got many examples to go through here. Here, look, you'll encounter surds. Once again, if you have surds, don't worry. Okay, surds is an acceptable form of a solution. Okay, so we'll keep moving on, and you've got some exercises here, right? Now let's move on to complete the square. This is 2.3, section 2.3 with complete the square. Clear that out. You can write quadratic expressions in another form by completing the square. So you can see here that x squared plus 2bx plus b squared equals this. And if you have a negative, okay, with the minus 2bx, then it's going to give you this form. And these are both perfect squares. To complete the square of the function, which we have here, you need a further term b squared. So the completed square form is as such. Alright? Literally all they've done is the difference between this one and this one is they've taken the b squared over to the other side. Similarly, you have the same thing for the other form. So they've given you an example here of 8 squared plus 8x. Okay? And so what they've done is they've taken x. Remember, our b in this case, or our 2b, gives us 8, and so b is 4, so it goes inside the bracket, and again we have the squared, and we, as is done here, take the b squared over to the other side, right? So let me just show you another example. So if we had, we can say x squared, right, plus 16x. Then all we need to do is, let's think about the form x squared plus 2bx plus b squared, okay, and is going to equal x plus b squared. So here we know that we have x squared plus, now this is going to be corresponding to our 2b, so that means that this is going to equal 16, which means b is going to be 8, right? So we can put this is maybe perhaps an easier way for you to spot it, bx plus 8 squared, right? So that means when it comes to this particular, the right hand side, we're going to have x plus 8, close the brackets, squared, and remember this is the form that we have, but remember that we need to take this to the other side, okay, as is done here. Then we'll have minus 8 squared. Okay, so it's very similar. I mean, I've just used a very simple example that hasn't moved on much from this one. It's just a different number has been doubled, so you can see that this has been halved, this has been halved. Okay, very simple, very straightforward. So it gives you a rule: completing the square, x squared plus bx equals the following. Alright, very simple rule that you need to write down, and I always recommend students to do this. If they don't have the best of memory at first glance, then all they need to do to ensure that they can remember it for the future is write it down over and over and over and over and over again. Literally, that's what you need to do. You need to write it over and over and over and over again. Okay, because that way you'll enable yourself to remember this when it comes to the exam, when it comes to a test, because your muscle memory will start to kick in. And many people who have done mathematics past A-level will tell you that these sorts of rules, okay, are second nature. They can do them in their sleep. Not literally, but just to emphasize how much they've done them throughout their mathematical academic career, that by the time they're in university, these equations, it's like a bread and butter. Alright? It's like your basic essentials. So again, you have these examples to play around with, okay? And then we come on to section 2.4. Section 2.4 discusses quadratic equations, okay, by completing the square. Now, it follows a similar idea to what we had before, except that you'll have an additional term here, okay, and it follows a similar theme or pattern in the sense that you are taking the number to the other side, okay, in order to create on the left hand side similar to what we had up here. Alright, so that shouldn't be too difficult for you to progress with. And then once you've worked out the method that you have here, you can then again take that number to the other side as we've just done, okay, with this particular example you can see here, right? And then once again just solve it. So compute this. In this particular example you have 6, alright, and then what they've done here is, in order to remove this quadratic 2, they've square rooted the left hand side. Likewise, anything you do to one side you have to do to the other side to retain that equality. So they've square rooted the other side. This is an important point to highlight, that whenever you have x plus 4, I'll just use this example to elaborate, squared 6. Whenever you square root something, right, we get the temptation to just put 6. But what we don't realize is, with this particular example, we have to always include the negativity sign. Reason is because, as we know, negative multiplied by a negative gives us a positive, and a positive multiplied by a positive gives us a positive, okay? So it's imperative for us to revert back to our original, which was 6 here, or any numerical number. It could be x, y, whatever you want to call it. Then we'll have to include the negativity, so do not forget that. And so this essentially tells you now, okay, once we've taken that term over to the other side, right, now obviously we can't compute this because we've got a whole number and what is essentially a decimal point, but you can leave it as this and you won't be docked marks. They'll realize that you can't go any further. And so the solution, the roots, okay, this is very important, they've called it the roots, and you can think of it like the roots of a tree. Essentially what it means is, going back to our graph, okay, it's what crosses the x-axis. Okay, remember we said on the x-axis y is equal to 0, and that's what they call the roots. So in this particular case we can say that the roots here, okay, on one side is going to be minus 4 plus the square root of 6, and minus 4 minus the square root of 6. I believe the square root of 6, no, I'm very sure the square root of 6 is less than the number 4. So in this case, the number, whatever it will be negative, and number, whatever it would be negative. So actually the points would appear somewhere here. So this is just an estimate to show you visually. Okay, so again you've got some examples going on and to play with, right? It shouldn't be too difficult. You've got some questions here that you can master, and then we come to the very infamous quadratic equations. And I think this requires a whole video to go through, because it's something that is done so often that it necessitates its own video. So we'll leave it at that. Thank you very much for listening. Do please share and subscribe to the YouTube channel for more videos. Thank you and goodbye.